हरि करना।
So as we have seen bootstrapping in our previous course, which is intuitive sampling and distribution course, distribution for you course, in that we have seen what is bootstrapping, and we have done a lot of examples in bootstrapping and how this bootstrapping helps, the bagging method helps us improve the performance of decision trees also we have seen there. So that's why we are leaving it for now, and we will be working on permutation testing only. So, understanding the permutation test. Permutation test is a resampling technique used to test hypotheses about the difference between two or more groups or two or more conditions. That's where the permutation test weighs more than bootstrapping. So, in a permutation procedure, two or more samples are involved. Typically, the groups in an A, B, or other hypothesis test. Means permute means to change the order of a set of values. That's it. That's what we call it as a permute. The first step in permutation test of a hypothesis is to combine the results from groups A and groups B. This is the logical embodiment of the null hypothesis that the treatments to which the groups were exposed do not differ. So we then test the hypothesis by randomly drawing groups from this combined set and see how much they differ from one another. The permutation test is this. So now let's look into the procedure. But before we look into the procedure, I would try to explain this much simpler way, the permutation test. So as we all know, permutation test is a resampling technique used to test the hypotheses about the differences between two or more groups or conditions. Again, I'm repeating. So it involves randomly permuting the observations in a data set, so creating a new data sets with a sample size but different assignment of observations or to groups, and comparing the observed test statistic to the distribution of the test statistic under the null hypothesis. So let's look into the procedure first, and then after that we will uh, do an example for permutation test. So the permutation procedure is as follows. It begins with the first step. It combines the results from different groups into a single data set. That is your first step. Combine the results of different groups into a single data set. If it is A B testing, A plus B, A data set plus B data set. If it is hypothesis testing, again, if there are some other groups, and bring the two groups into together and make a single data set. That's our first step. What's next? Shuffle the combined data and then randomly draw a resample of the same size without replacement. Very important point to be noted. Without a replacement of the same size as group A. Clearly it will contain some data from the other groups, obviously. So once you have combined the results of two different groups into a single set, then you have to do the shuffling. It's like cards game. Once you combine all the cards, you do the shuffling like this. So it's like a cards game. You shuffle the combined data and then randomly draw a resample of the same size as group A. Let's take it as a group A. That's a standard one. So group A, and most important point to be remembered when you draw a sample, it should be without a replacement. Without a replacement. If it is with replacement, it's a bootstrapping. Without a replacement, that's your permutation procedure or permutation test. So obviously that group A will contain some data from other groups also, because the data was combined and then reshuffled. Now third step, From the remaining data, randomly draw a resample of the same size as group B. One sample with the size of group A, another sample with the size of group B, and the point to be noted is without replacement. I'm screaming out of my head, without replacement, so that it will be noted in your brain. Okay? Then, then the fourth step is to do the same for groups C and D. If you have more number of categories, you have to do the same for groups C and D and so on. If you are just doing A B testing, in that case you don't need to do all those things. Just two groups, group A, group B is done. If you are doing for more than four groups or five groups, and you have to do the same for each group, and then you have now collected one set of resamples that mirror the sizes of the original samples. One set of samples, one set of resamples has been collected with this. After doing the four steps, one set of resamples were collected. What next? Then whatever statistic or estimate was calculated for the original samples, example, the difference in group proportions. So that's the statistic, one statistic you can take. Calculate it now for the resamples and record. So this constitutes one permutation iteration. Okay, this constitutes one permutation iteration. Whatever statistic it could be mean, it could be difference, it could be proportion. Whatever statistic or estimate was calculated for the original samples, you do it with the resamples also and record it, and this we call it as a one permutation. Till now whatever we have done is one permutation. Then you have to repeat all these previous steps again. This one, or repeat all this previous step r times to yield a permutation distribution to the test statistic. Then you repeat all the steps, sorry, you repeat all the steps, shuffle it, and then resample A, B with respect to their sizes A and B, and then whatever estimate the statistic. And then if you do all n times or r times, if you do it 1,000 times, you will get the 1,000 statistic, 1,000 statistic or 1,000 estimates. So now if you put it on the plot, if you put it on the graph, the frequency of each statistic, that's what is your permutation distribution. That's what is your permutation distribution. So now go back to the observed difference between groups and compare it to the set of permuted differences. If the observed difference lies well within the set of permuted differences, then we have not proven anything. The observed difference is within the range of what chance might produce. However, if the observed difference lies outside the most of the permutation distribution, then we can conclude that chance is not responsible. In technical terms, the difference is statistically significant. The difference is statistically significant. So that's what is the procedure to do the permutation test. Now let's look into one example for permutation test. Okay, suppose just a minute. Yep, now it's fine. Yeah, comfortable. So permutation test. Suppose example, a researcher wants to test whether there is a significant difference in the average weight between two different breeds of dogs. That's breed A breed A and breed B. These are the two dogs. Okay. So null hypothesis for this is that there is no significant difference between the average weights and average weights of the two breeds. So while the alternate hypothesis is there is a significant difference. Okay, that's what is our alternate hypothesis. Okay, this is what a researcher wants to test. He just want to check the significance, and then this is our null hypothesis, and this is our obviously alternate hypothesis. Now let's get into the action. So the researcher collects a sample of 20 dogs from breed A and 20 dogs from breed B. Okay. Then after the collecting a sample from breed A and breed B, and he measures their weight in pounds. So now after doing that, he observed observation step 2, the observed difference in means between the two breeds is 4.5 pounds. 4.5 pounds, with breed A having an average weight of 45 pounds, and breed B having an average weight of 49.5 pounds. So that's what the observed difference in means between the two breeds. We got the 4.5 pounds, and this is what the average weights of breed A and then breed B. So breed A is 45 pounds and breed B is 49 pounds respectively. Now let's conduct a permutation test. Step 3. Step 3 is conducting a permutation test. To conduct a permutation test, the researcher randomly assigns let's see this process very now vigilantly. So the researcher randomly assigns the 40 observations to two groups of 20, because both are of same size. So that's the reason, two groups of 20. And then once that is done, we have to simulate simulating the null hypothesis of no difference between the two breeds. So the researcher calculates the difference in means between two groups and records this value. So this process is repeated many times, maybe n times, is equals to 10,000 times. Now creating a out of this differences. So this process is okay, let me put it in separate one. Then step 4. So researcher calculates the difference between the two groups. Researcher calculates the difference in means between two groups and record this value. So this process is repeated many times, creating a distribution. That's it. A distribution of differences in means under the null hypothesis. That's it. Then after creating the distribution, it's all done. Step 5. After creating the distribution of differences in means, this is our statistic here. The researcher compares the observed difference in means of 4.5 pounds to this distribution. So if the observed difference, let's see, if the observed difference, the initial observed difference, what we have calculated from the actual data, not from the resampled set, not from the resampled that set. If the observed difference is outside the range of values in the null distribution, in the we call it as a null distribution, or it's okay, we can call it null distribution, or the distribution whatever we have, or the distribution of differences in means, or differences distribution, null distribution, or distribution of differences in mean. If the observed difference is outside the range of values in this distribution, then the researcher can reject the null hypothesis. If it is out of the distribution, the researcher will reject the null hypothesis, because we have taken the we have taken the way of null hypothesis. We have taken what is null hypothesis? Null hypothesis says there is no difference between the group A and group B. Okay, that's what null hypothesis says. There is no weight difference between this and that. So that is the reason we have combined the two groups and then we have taken the sample. So that's the reason whatever distribution you make with this resampling data, that is a null distribution. We call the distribution as a null. So that is the reason if it is falls outside of the null distribution, we will reject the null distribution. Very simple. So researcher can reject the null hypothesis and conclude that there is a significant difference between the weights of the two breeds. That's it. And permutation, final closing remarks. So permutation testing is a powerful technique for testing hypotheses especially when the sample size is small or the underlying distribution of the data is unknown. However, it can be computationally intensive and requires careful consideration of the appropriate test statistic and test design.